Hello everyone, welcome to Pepcoding. In this video, we will look at the question, find the element that appears once in a sorted array. Okay, so let's see. In this question, we have an array like this, right? And uh, all of the elements here have duplicates except one. And we have to find that one element which does not have any duplicates. Okay, so let's see. We have 1, 1, we have 2, 2, 4 is alone. We have 6, 6, 8, 8, and 9, 9. Right, so it means that we have to find this 4 element, right? We have to return this 4 element uh, because the rest of the array, or because all of the rest of the elements have a duplicate, but this 4 does not, right? This 4 is single, so we have to return this 4. Now you can solve this question very easily using O of n time, right? But in this question we will apply O of log n, right? We have to solve this question in O of log n. And how will we solve this question in O of log of n? Using binary search. Okay, so before going to the approach, first let's discuss about the size of this array, right? The size of this vector. So the size here is 11, right? What I'm trying to say is there is not going to be any case where we have a situation like this where there is one element which does not have any duplicate. There is not going to be any situation or any case where the number of elements or the size is even. So if even size, let's say I have size as 6, right? And I make 1 1 2 2 3 3, right? I make a array like this. I have a vector like this, 1 1 2 2 3 3, right? Now in this vector, what are going to be my pairs, right? This 1 1, this 2 2, and this 3 3. But if I want another pair, if I want another element, and I want a separate element, right? I want a unique element, but there is no space for a unique element here, right? Even if I decide to change one element, if I say 1 1 2 2 3 and 4, if I try to write it something like this, 1 1 2 2 and 3 4, then the purpose of this question is defeated, because here it is 1 1, here it is 2 2, then 3 is different and 4 is different, right? 3 is different and 4 is different. So it means that the question was asking that I have to return just one distinct element, right? But here for this case there are two distinct elements. So the purpose of the question is defeated. So there won't be any case where we would have a single element in an even size array, right? We cannot have a single element in an even size array because all of the elements would be paired up with at least with someone. So I hope this part is clear, that the only way we can have this size, the only way we can have this situation where one is not where one element is alone and the rest of them have duplicates. This is only going to happen when my size is odd. This cannot happen in even. Okay, this cannot happen in even size. And why am I emphasizing this point so much? Because the basis of our binary search for this question is going to be this only, right? The part where which we divide, right? And we traverse some parts, right? So let's say I have this, that if I want to decide to go here, I do that on the basis of this part, that I will find my answer on the odd size. So if you don't understand this, we'll parse this once, and then it might be much clearer. Okay, so let's say I have this low and I have this high. I'm going to parse this once. Okay, I have this low, I have this high, and I find my mid. My mid is going to be 6. Okay, now what is going to be my condition that my element is the element that I want to find, or it is the only single element? How will I check that? Right, let's say I'm at 6. For 6, the element just before it and the element just after it, both of them are not equal, like both of them, one of them is equal to 6. Okay, so let's check this for 4 only, because we know my 4 is my answer. For 4, the element just before it is not equal to 4, the element just after it is also not equal to 4. Okay, so this will mean that 4 is my answer. Let's say this is, let's do the same for 6. For 6, my the element just before it is 4, the element just after it is 6. Now 6 is equal to 6, right? It means that that one of the elements, or one of it has at least one of the duplicates, right? Since my array is sorted and every element has one duplicate, then the duplicate is just going to be either on either of its side. So let's say this is my mid. So I've derived this condition that if my mid is not equals to mid minus 1 and mid is not equals to mid plus 1 also, right? If this is true, then that mid is going to be my answer, right? That mid is going to be my answer. Let's say for 4, 4 is not equal to this, 4 is not equal to that, so my answer is going to be mid itself. Okay, else if I can have two conditions, either it is going to be equal to the left hand side or it is going to be equal to the right hand side. Okay, so here 6 is equals to the right hand side, so we can take this condition where mid is equals to mid plus 1. Okay, one condition this, and else if we are in this else block, it means that 6 is equals to the one on its left. Okay, so let's try to find the answer for this. My mid is here. Okay, now we will see if my mid is equal to the left hand side or the right hand side. So I'll make this check. Okay, it is not equal to its left, but it is equal to the right, so it won't go into this condition. Okay, so it will go, now mid is equal to mid plus 1. Okay, so it will go in this condition. Now we are in this block, right? We are at this mid and we see that mid is equal to mid plus 1. Now we will try to find RC, and here we will find LC. Now what is RC and LC? RC is my right count. Right count means that it is the count from my mid to my high, right? It is going to be the count of my mid to my high. And why am I trying to find this count? This count will represent the size of the binary, the size of the array or vector on which I am performing the binary search, right? So I know that I have to travel to the direction where the size is odd, right? I only have to go, or I only have to search in that array or in that sub array where the size is odd, because I'm only going to find that element in this in the part where the size is odd, right? I cannot find the size if it is even. I cannot find the element if the size is even. Okay, so let's say I have this. Now from 6 to high, I check my right count, right? My right count comes out to be 6. 1, 2, 3, 4, 5, and 6, right? So my right count is 6. Now I'm at this point. After this, I will check for the, okay, so I'm at this right hand side, right? It checks if it is even or if it is odd. It checks if the value of RC is even or odd. Now if it is even, we already know that if it is even, and all the elements on the right hand side are in a pair and we cannot find our element there. So there is no point in looking in the right hand side. So we are going to search on the left hand side. Okay, so we are going to search on the left hand side. So from here to here, right? My new low is going to be mid minus 1. Okay, and this, let's delete this mid. Now this is my new low, this is my new high. Okay, so now my mid is going to be 2, right? My mid is going to be at second index. Now I will check if my mid is equals to my left or my right, right? If it is not equal to my left and not equal to my right, but this condition fails again, but is because it is equals to my right hand side. So my low, okay, so since it is equal to the right hand side, I will check the count of the right hand side, right? And the count of the right hand side comes out to be, the right count comes out to be 3, because 1, 2, 3, right? I have 3 elements on the right. So If my right count is 3, it means it is odd, and I have to check on the right hand side. So I have to move my low to the right. But where am I going to move my right, or where am I going to move my low? It can either go to my mid only, it can either go to mid plus 1, or it can go to mid plus 2. What is going to be the deciding factor? Right, let's see. If I move my low to if I move my low to my mid, right, my condition would be for 2, 3, and 4. But I already know that 2 and 2 are equal, right? These two are equal, right? These values are equal, right? So I don't have to check for these values. So there is no point in moving low to the mid. What if I move low to low plus 1 or mid plus 1? If I move low here, if I move my low to mid plus 1, then it means that my value, or it is going to search in this part. But now I know that 2 is not, but here 2 is moving as a single element. Now what I'm doing is I'm dividing a pair up, right? 2 and 2 is a pair. But if I decide to search in this range, then 2 is not a pair. 2 is not in a pair, and it is divided up, right? And we don't want that. So we're going to search, and we are going to skip these two elements. We are going to skip 2 and 2. So we are going to skip these two, and we're directly going to go to our mid plus 2. Why mid plus 2? Because I know that mid and mid plus 1 are equal. So I don't need to check for these two values. I just have to go to mid plus 2. Okay. So my low transfers to mid plus 2. My new mid is going to be at this point only, right? So for 4, now for 4, I will check if it is equal to my left or if it is equal to my right. It is not equal to my left. It is not equal to my right. This is my answer, right? So I'll return my 4. I hope you understand this question. Now let's try to code this. It is very, this might be a little confusing, but as we code, this would be much clearer. Okay. Okay. So now let's first try to find, let's find the size. Okay. So n would be array dot size. Now I have my array size. Now I need to check if my size is equals to 1. If my size is equals to 1, it means that there is only one element in my array. And if there is only one element, then I just need to return that element because that is the only answer. Now I'll make another two checks. If array of 0 is not equal to array of 1, and if array of n minus 1 is not equal to array of n minus 2. What are these two checks? Let's see. Let's say I have a test case like this: 1, 2, 2, 3, and 3. Right? If I have a test case like this, in this part, you can see that for 3 or for 1, it is not equal. It is not equal to my right hand side. So it means that it is the only unique element, right? Because if it were to be equal, then my only single element would be on the right hand side somewhere. But if it is not equal, then it means that it is only going to start from here, right? And if I handle this base case early, then I won't have to worry about the left count and the right count, right? So uh, the same goes with that case, that where this is 1 and 1, this is 2 and 2, and let's say the last element is 3, and for this last element, I'm just going to check that if this last element is equal to the second last element. If they are not equal, then this last element is the unique element. Okay, so I'll just return array of 0 from here, and I'll return array of n minus 1 from here. Okay, this means that this is the first element is unique. This means that the last element is unique. Okay, after that I've done my job, so I'll just go to my binary search. My low is going to be at 0, my high is going to be at n minus 1, while low is less than high, right? While low is less than equals to high, my mid is plus high by 2, right? I know my mid. Now I will do my two checks. If array of mid is not equals to array of mid minus 1, and array of mid is not equals to array of mid plus 1. Okay, these are the two cases. This is the first case where my current element is the answer, right? The next case is going to be if array of mid is equals to array of mid minus 1. If the first element and the previous element are equal, or if my current element and the next element are equal. Okay, so these are my three cases. If I'm in this case, if I'm in the first case, it means that I'm the current element, so array of return array of mid only. Okay, if I'm in this case, if I'm in array of mid equals to array of mid minus 1, this means that my current element my current element is equal to the previous element, so I need to find the left count. Okay, so my left count is going to be mid minus 2 minus low plus 1. So what is this? Why did I choose this as my answer? Let's say I have this array 1 1 2 2 3 3 4 5 5 6 and 6, right? This is 0 1 2 3 4 5 6 7 8 9 and 10. Okay, so my mid here is going to be 3, right? For this case, my mid is 3 and the previous element is also equals to 3. Now I can either choose my count from this point to this point, or I can choose my count from this point to this point. I'm trying to find the left count, right? So I can choose my count from either here to here, or my count from here to here. Choose my count from this point to this point, right? This would add this up and this would make this odd, right? And this would say that the answer is going to be on the left hand side, but the answer is actually on the right hand side. It's this 4, right? So either I can choose this or I can choose this. So I'm deciding to choose this. I'm starting from mid minus 2 and this is at low, and my formula is mid minus 2 minus low plus 1, right? So I'm doing that only. Now if this LC modulo 2 is equal to 1, which means this is odd. If this is odd, my high would be mid minus 2, right? My low would be mid plus 1. Now what is this? It is saying that if these two are equal, then my high should shift to here, right? If the value of this part is odd, then my answer is going to be on the left hand side. So I need to shift my high on the left hand side, right? So high would be shifted to mid minus 2 because I know that my current element and my previous element are equal. So I need to shift my high to mid minus 2. Else, I'm going to shift my low to mid plus 1. Okay, so my low would be here. So this is my part for when my current and previous are equal. And this is if my current and my next element are equal. So if this is equal, then my RC is going to be high minus mid plus 1. Okay, so here we have a case where where it is something like 4 and 4, 5 5 6 6, right? Let's say this is my case and 4 is here. Now this and this element are equal, right? Mid and the next element are equal. And since these two elements are equal, I'm trying to find the right count, right? So I can either find the count from here to here, or I can find the count from here to here. It does not really matter, but I'm trying to find the count in this case, I'm finding count from here to here. Okay, that is high minus mid plus 1. Okay, so it would be my if my RC modulo 2 is equals to 1. This means that this is my answer, or this is the odd part, right? And if it is odd part, then my low would be mid plus 2, else my high would be mid minus 1, right? Because if these two are equal, then my low should shift here, and this is my mid. This is mid plus 1. This is mid plus 2, right? This is mid plus 2, so my low should shift here. Okay, so this is my code. After this while loop has run, I will just return -1. It means that I did not find something. Okay, I did not find that element. Let's run this. It is accepted. Let's submit this code. It has also passed all the test cases. So I hope you understand this question. If you don't, I would suggest you watching the part which you don't understand. Don't forget to like, share and subscribe. Thank you for watching.